5, 4, 3, 2, 1.
We have ignition.
So one of my go-to sites for keeping up with just artificial intelligence, or this is really analysis of, they call it analysis of AI, but specifically like large language models and how they're progressing in terms of their benchmarks, their intelligence, their speed, their cost, is this website called artificialanalysis.ai. So what I really like about this is that they've updated this site now. I actually think this whole effort or this project has got funding now. So they've kind of turned this into an actual funded project, which is interesting.
Yeah.
But essentially what they do is that if I scroll down to this intelligence tab here, they aggregate multiple different benchmarks for large language models, and they create this like synthetic composite benchmark to try and rank them in a consistent way, whether it's an open source model or whether it's a proprietary model like from Anthropic or from OpenAI. So what's really interesting is that you kind of can slice and look at the intelligence benchmarks in different ways, especially for what matters to you. So they have their so-called artificial analysis intelligence index, which you can see here is 9 evaluations. These are all just basically different tasks that different labs have put together and open sourced that try to measure a specific thing. For example, how well models can call tools to build agentic workflows, how well models can write code, how well models can reason, how well they are specifically like scientific intelligence, how good are they at that? Are they good at solving math? And so on and so forth. So this composite index, this is kind of as of right now, so mid-July 2026. Fable 5 is kind of at the top of the list still with this composite benchmark. But what's interesting is if you look at like just the coding index, GPT-5 Max, GPT-5 Soul on max reasoning is actually the highest performing, followed by the 5.6 Terra model. So these GPT-5 models just came out this week. It's like OpenAI's newest flagship models, where they've kind of taken a similar approach to naming that Anthropic has. So before, they would basically call their models like GPT-5, like Pro, just regular, Mini, and Nano. So now they're trying to like brand them a lot more, I'm assuming, because that's what Anthropic did. So Anthropic has like the Haiku, Sonnet, Opus, and then now Fable and Mythos. So now they, as you said earlier, I like my models ranked by the mass of the planet rather than the length of the poem. So, so we've got Terra, or Luna is the smallest, Terra, kind of the medium one, and Soul is the biggest one, and they're all GPT-5 from OpenAI.
Do you know, is this scale? Is it like logarithmic or like exponential, or is it linear? Like, do you have any idea how it's weighted?
This right here, the actual composite index?
Yeah, just like the index in general.
How I actually
0 to
don't know
100.
off the top of my head, like what the values even mean. I think that they're just meant to be relatively ranked. So whether the number is 100 or 6,000, I think the most important thing is just seeing how close they are relative to each other. And kind of seeing the spread. Honestly, you're right. It probably would be best to know, is this like a 0 to 100? Or is this just like a arbitrary number that's greater than 0? I'm not 100% sure.
Yeah, I'm like, if you pay up for Soul versus Terra, are you like, what are you getting there? Because I don't know what the price difference is, but I think it's probably more than.
So that's a good point. And the way I kind of think about this and look at it is that this is just kind of one dimension. If you try to stack all these dimensions on how you can rank a particular model and how good it is at doing something, whether you can measure it well from a benchmark that's official, or whether it's just like a totally vibes based thing, like I just like how this model responds, or I like the code that this model writes. Those are all just different dimensions, and this is an attempt to collapse them onto a single dimension. But if I scroll down, and I'll show you here in a sec, there's actually different ways that you can rank them. And to your point, one of the most useful ones is looking at cost per task. So it's not just how many tokens does this model take to do a task, because different models are trained very, very differently. Some use a lot of reasoning tokens, some use less. Some are very verbose in their outputs. It gets even more complicated when you include the harness that the model is working in. So how good is the harness for the task that you're doing? But all that considered, I think the best kind of two dimensions that you can look at is, I think it's price per task, which I want to see if they have this down here. Okay, they've got intelligence versus cost per task. So I believe a task is just defined as like, one of these benchmarks, perform something, and they have a verified way to check that did the model succeed or not. So what's interesting on this graph, the x-axis is logarithmic on the cost, and the y-axis is just that intelligence scale that we were just looking at. And so this is where you see that Pareto front, where you can kind of see that if I, drag my mouse across the board here, this kind of if I draw this line, especially because it's in logarithmic scale, you can basically, this is the best that you can do for a given amount of money. So if you want to improve your performance, you just have to pay more money, typically either for, a better model or increase the reasoning for a specific model. And so to your point here, this really depends, right? If it's something that, let's to compare a 5.6 Sol to 5.6 Terra, the comparison here that it looks like, Sol on this specific benchmark does a slightly better job by 4 points, but it costs almost twice as much to perform the same task. And so I think this is where it comes down to evals for your own business and for your own use cases, which can be really hard to do because, you can't just, every business is not just, is this piece of code correct or not? Or these things are hard to verify and they're hard to kind of judge, which is why doing evals is difficult. But that's why I think it's really important to kind of nail down what evals are important to your business, because then you have this freedom to explore and decide, what is the best model for the use case? Do we have to be paying for this? Does every business need Claude Fable 5 for every single task? The answer is no. Like that would be overkill. But the question is like, okay, should I be using, a 5.6 Terra? Grok 4.5 just came out this week as well, and it's been showing really, really excellent results. Is that good enough? It's excellently priced, very, very cheap relative to the quality that you're getting. So these nuanced decisions are where it comes down to the evals and actually evaluating the model on your specific internal use cases and seeing how well it does. Because if you have a metric and, depending on what you're optimizing for, it's not valuable to you to have a 0.5% increase in quality relative to, doubling your cost, then there's no reason to go up a stronger model. But if going up a basis point,
depending on the task,
but if going up a basis point and doubling your cost is like absolutely worth it because you're going to quadruple your revenue or your whatever on a relative basis, then absolutely you should. So that's where it really depends on the economics of the problem you're solving.
Yeah, it's very similar to like distributed system benchmarking, where you have like micro benchmarks where you look at a exact task that needs to happen on the system, and you look at like the latency of executing that task, and then you look at like a workflow end to end, and you really are trying to measure more like throughput or latency of like a sequence of events. It's like pretty much the same thing here, right? I mean, these models are all just distributed systems on the back end that are trying to figure out how to get you the correct insight for some optimized costs internally. So it's funny because it's almost like just because of the way it's now been rebranded as AI, or because like you're using LMs in the back end, it's like this abstraction that I think's not like scary, but almost like there's just an assumption that it's a magic box. And I feel like anytime like a new technology like this comes out that really is just like a distributed system that's doing some function really well, people, or at least sometimes my inherent reaction is like, oh, I don't know like what that thing is or how it works, so I just don't do any more than just call this API that gives me a magic answer. And as you get more familiar, like, oh, actually there's like 100 different flavors of this, and it really is just like one piece of this distributed network that I'm building for my product.
That's the beauty of these open weight models. And I mean, as far as I'm aware, I could be wrong here, but I think specifically with neural networks, I think there's two big reasons why these things have been deployed behind APIs and now they're closed source. The first, I think, one is a practical one. First of all, these massive models are extremely resource intensive. You need huge clusters of GPUs. You just need like massive infrastructure to be able to even serve and do inference. And that's why we've all seen the astronomical rise of RAM and the cost of GPUs and hardware, because it's all just affecting the entire supply chain from the bottom up, is just kind of rushing to deliver these raw materials, these resources, all of this hardware to this huge demand business for GPUs and essentially specialized hardware that is really good at performing matrix multiplications so that you can do inference. And so you're at the point where that's why there's just a small handful of labs it's just a big race to secure as much compute and resources as possible and make that economically viable to people through an API and then basically metering it on a per token basis so that the economics will hopefully work. That's a whole other discussion on like whether or not these AI labs will ever even make money or not at the current spend rate. That's not an area that I'm, let's say, as familiar. I just know that given all the R&D costs, all of the inference costs, like just the huge amounts of how capital intensive serving LLMs are and doing training, it is a big question on like, man, these commitments that companies like OpenAI and Anthropic are making, like, are they going to really pay out in terms of the, in the next, 5-10 years, given how much capital these companies are raising. So, and the second point that I wanted to bring up, so the first one was kind of, the resource intensiveness, that it's very difficult. I can't just, on my consumer level GPU, run a model that's the size of, GLM 5.2, which is currently the strongest open weight, open source model that's available on the market. I would need 4 or 8, what are those, A100s or H100 GPUs? Like, it's just, I think I did for fun, I priced out what it would look like to have a decent inference, like on a tokens per second, running at the same like performance level that these providers would give you. And it would cost like 20 to 30 grand in GPUs to be able to run the model locally. So these are massive models.
Saying?
Yeah. So there are ways to do that. There are ways to do kind of clever, this is going to get it like really into the weeds, but essentially depending on the structure and the architecture of the model, there are ways that you can essentially only load parts of the model in memory and, use that for inference and then offload the rest of that onto disk, so that you don't necessarily need to hold the entire model in memory at once to do inference. There's all these like really specialized, clever techniques and hacks that really smart people in the community are putting together to be able to kind of like do this stuff on consumer hardware to the best of your ability. I actually did see a project for GLM 5.2. It was like a specialized kind of software that allows you to do inference by only loading a part of the model. Since GLM, I believe, is a mixture of experts model, which means there's essentially, think of it as like, one brain with 10 different specialists, and like, depending on the task that you invoke, it only needs one part of that brain. So you only load that expert. That's why it's like a mixture of experts. So the model itself may be, in the hundreds of billions of parameters, but the ones that are actually active during inference when it's answering a question may only be a fraction of that. And so kind of it uses that fact in a clever way to offload the rest of the model to disk and only load that into RAM or into VRAM to be able to do inference. But I mean, these are all like very specialized things.
Mhm.
But I'm very interested, and that's why I'm following this stuff really closely, obviously for work as well, because of what we do. But I'm very, very interested to see what the, performance of the best open weight models will be in a year or two from now, relative to their size. So, you have models like Gemma 4, which is an open source model from, or I should say open weight model. There's a slight distinction. It's an open weight model from Google. It's like the open weight Gemini companion called Gemma. So Gemma 4, I think there's 3 or 4 different variations of that, different sizes, and you can definitely run those on a beefy, Mac Pro. And you can certainly run agentic workflows. You can code. It's just obviously the quality is not what it is if you're using GPT 5.6 or Opus 4.8.
Can you just
But
explain quick what open source versus open weight, what the difference is?
yeah, there's a little bit of a nuance, and I mean, I'm sure that I may not perfectly hit the exact nuance, but the high level idea is that you have, like, what is a model? A model is in essence a snapshot of different parameters, different weights. Weights being, a value that represents a connection in the neural network, the edge between 2 different nodes in a neural network. And so these large language models are these very, very massive transformer architecture neural networks. And once you've trained them, the artifact that you produce are these weights. Like if you take the weights themselves, that is the intelligence of the model. It has figured out that when you pass it in text and it turns that into numbers, and
Mhm.
it feeds that through the network and it produces some output numbers, and then those are decoded back into text.
So it's like a probability distribution across
It's
whatever, a billion variables.
Yeah. So if we just start with the most basic neural network, or just a single neuron network, where you just have or maybe just a single neuron network where you just have input and output. Um, that can be essentially thought of as just a very simple linear regression. You have a matrix of inputs. You need to figure out what the weights are that you can attribute to each of your variables, and you multiply the inputs by the weights, by the parameter, and you get some output value. So we learned that in in middle school, y equals mx plus b. Simple linear line. You have to figure out what m is in this equation. That's for a really simple 2-dimensional problem, or 1-dimensional in essence. If you ramp that up into more than 1 dimension, multiple dimensions, hundreds of dimensions, that's essentially what words are when they're turned into these embeddings. And so you take a corpus of 50,000 different words, however many, I don't remember off the top of my head what the corpus of like GPT-5 is, but
Like what its dictionary is.
yeah, what its dictionary is. Take all of those, you turn them into tokens, which are just kind of these representations of parts of a word, or kind of the stem of a word. And you turn them into these numerical representations, which we call embeddings. And there's a whole process by which you do that. And that embedding is essentially just a huge matrix. It's a multidimensional matrix. And so then, you feed this this input through your network, and the process of training it is figuring out and determining what the optimal parameters are to achieve some output. And so, without going too much more into it, because I think we've kind of got definitely a lot deeper than you might have wanted. Think of the final artifact of the model itself as these parameters. It's the final trained weights that represent the intelligence of the model. And you can export those in a file. There's different specialized files that you can export them and load them to run inference. So when we say open weight model, it means that these files can be downloaded. They're freely available. You can go to Hugging Face, which is a kind of like the biggest open source hub for neural networks models, large language models. And you can literally download these files and have them on your computer. Now, whether you can run them or not, probably not. But if it's a tiny model, you absolutely can download the model. You can download the software that's necessary to run the model and do the inference. And you can set it up and run it. There's, projects, the really famous llama.cpp is basically an inference engine that allows you to run inference on these models on a CPU without necessarily needing a GPU. So open weight. If something is fully open source, the distinction is
just to reiterate that. So open weight means that that the model is able to run on this kind of like standardized set of embeddings. So like you have some kind of publicly available set of embeddings that you can upload into the model, and the model can just take that and then actually execute like natural language queries.
Not quite. And I think I should probably phrase it. I should have started a little bit differently to kind of frame the question a little bit better. So when you have something that is, let's start with something completely closed source, right? I can't go and see what the architecture is of GPT-5.6.
Mm-hmm.
I don't know how big of a model it is. I don't know how many parameters it has. I can't go and download that model myself and just use it. I have to rely on OpenAI through their API to use their model. So that's a completely proprietary closed source model. So let's start there, right? At the proprietary. Then you have a model like GLM 5.2 where it's open weight, meaning that the actual source of the model, the output of the model, not the code that produced it and the data, that's the distinction. The actual artifact, the thing that came out of the engine after training, is available and you can go and download it and run it yourself. That's open weight, meaning that like the weights themselves, the artifact that is produced as a result of training is available for you to download and use and run it yourself if you have the hardware. Going to like the full end of the spectrum,
meaning
open
like that's
source.
Just like some binary file that you can like run as an app on your computer or something that you can. Like when you say,
think of it like
artifact, yeah, okay.
But then when we make the distinction of like fully open source, that typically means that you have the code that was used to train the model, the data that was used to actually train the model as well. There's like papers and documentation that show you, that describe the architecture of the model and what the actual like pre-training process looked like, how they fine-tuned it, how they did all the reinforcement learning, and you have that actual source code available to you, so that theoretically you could take all the data that they used, you could take the code that they used, train the model yourself, and produce the same artifact that they did. That's a distinction between like fully open source, where the code, the data, and the artifact is available, the result, versus just an open weight model where it's like the AI lab has proprietary code that they've written. They have a proprietary data set, but they make available the end result to its users.
Okay.
Does the distinction make sense?
I think at a high level it does. What I'm really curious about is like on these open weight models, like what do the artifacts look like? And are they transferable across? Basically, like how standardized are they? Like, is there a common model for like embeddings or like a common dictionary somewhere that like, I'm just wondering like how much can you kind of cross?
Yeah,
so you're trying to stand up your own, you're trying to stand up your own, whatever. I come into some money and I've spin up a GPU cluster. So I have a whole bunch of computational power, and I have a set of different open weight artifacts that I want to use and maybe build my own kind of gateway or like system where I can, depending on what I'm trying to answer, I can, call out to these different open weight models that I'm running on this cluster. Like, how standardized is that? Because I feel like a lot of the time when I listen to, kind of like industry experts, they talk about this like it is such a unlocked space, like it's pretty straightforward process to do. But then as, an engineer myself, I'm like, well, it doesn't sound that straightforward. And a lot of the time, like what these closed weight systems what these, closed source systems are doing is they're doing a lot of the decisioning around when to kind of walk which path through their internal system, right? Like they have an algorithm to kind of parse a prompt and figure out which pieces need to be answered via which segment or like which set of cached contents. And like that's part of how they get, I'm sure a lot of cost savings in the back end and like build some margin for actually, being profitable maybe one day. So yeah, I'm just like curious how transferable these different like open weight models are.
So at this depth, I am a little bit out of my element, but what I do know is that there are some form of standardized, let's say, outputs. I know that the format that I believe Llama CBP uses is called a GGUF format file. And so in essence, because remember that what you're storing or what the artifact is just a huge matrix. So you have to be able to store that in some way. This isn't something necessarily new. That there's been different softwares and different, there's been machine learning models before where you have these artifacts and you can save the tensors in some particular way. And every vendor, every open source model might have a different format. I know there's a format called safe tensors. There's GGUF. There might be more that I'm just not very familiar with. I haven't really worked deeply at the actual like inference level. But to your point, it's not like it's like fully standardized. There are decisions that you can make. There are these like very fine decisions on like how the architecture is designed and how it's built. What inputs, like what's the, like you said, the dictionary or the tokens that it supports. I know a lot of these models, like you don't necessarily have to use your own tokenizer, but that is something that you have to be aware of. I think that a lot of them, when you provide text, the way that they're bundled together, it bundles the tokenizer. If I'm not mistaken, I could be wrong here, but if you try to like break out these components into try to like break out the constituents and do things differently, that's where it requires a lot of expertise. And companies like essentially Fireworks, Cerebras, what is it, Nebius. There's all these, actually here, I have this open on API provider latency. Yeah, all of these. Together AI, Grok, Novita, Deep Infra. Like, you might ask, like, what are all these providers doing, right? These are not all proprietary AI labs, but where they're competing is giving the best quality, the best performance, and the best kind of user experience to users, to give them essentially the trade-off between speed and latency, like how fast they can serve models in terms of tokens per second, or the latency, like how many milliseconds or seconds it takes before the model returns its first token. And being able to actually operationalize these models, even if they're open weight, the leading ones are still massive. Like we just talked about, GLM 5.2, Minimax M3, all these like top of the line models are still massive. And so they're competing on expertise, like proprietary knowledge and expertise on how to take these models and operationalize them better than their competitors. And so it's a really interesting thing, because if we look at this speed versus latency, I actually, there's a graph somewhere that looks at just open weight models, I believe. Okay, here's a good example actually. So GPT OSS 120B, this is an open weight model released from OpenAI, I believe about a year ago. So they released this. It was kind of a surprise to people. They're like, oh, here you go. Look, we're still an open company. It was kind of funny. It's actually quite a good model for its size. 120B. So that basically means that it has 120 billion parameters in its network. So by older conventions, this is considered a massive model. By new conventions, like the post LLM era, this is considered a small model. And so here's what's super interesting. You can see the competition here specifically on like pricing and how different providers price their tokens for the exact same model. So CoreWeave and Deep Infra and Ovida, they're competing primarily on price, that we're going to give you this exact model as cheaply as possible. Whereas companies like, Cerebras and Grok specifically that I'm aware of are competing on, it's going to cost you more, but they give you blazing performance, and they have all these really, really smart teams and people that have built inference stacks that can take these, that, they understand how to take these open weight models and write the software that can do inference at a much faster speed using all these really clever tricks that I'm not, very well versed in. Does that kind of make sense at a high level?
Yes, just to zoom out, like, I want to try to put it back into layman's terms as much as we can, in case anyone's listening. So like a token ultimately is like a word or segment of a word.
Yeah, think of it as basically a word-ish.
Yeah.
It's a word-ish.
Okay, so either on the input or output, there's this notion of tokens, which is like what we use to transact with a language model. So like when I go to ChatGPT and I say like, what should I wear today? There's a few tokens in that prompt. ChatGPT comes back to me and says, I think you should wear whatever. There's that's a tokenized output from ChatGPT. So that's kind of the currency at a high level, is just spoken or written language. And then internal to what's happening behind that, that little web UI or wherever you're interacting with the model, there's this kind of sequence of a whole bunch of infrastructure that tries to optimize via like caching or like work or, orchestration of transactions downstream with the language model. There's a whole bunch of kind of this middle layer or middleware of like things that can happen with those tokens, right? To try to optimize costs or to try to optimize latency. Depending on the model, they're probably making different trade-offs. And on the back end, like the very back end inside of this kind of brain or neural network of the language model, there's these massive matrices of a whole bunch of parameters. And internal to those, there maybe not all, I'm guessing that like sets of parameters or subsets of parameters are kind of hosted inside of different matrices. Like if you were to look at kind of the LM from like a more mathematical angle, it's like they probably have some sort of matrix that does some kind of decisioning and picks other matrices that maybe need to be called out to. And those are hosted. There's a certain amount of memory it takes to actually stand up one of these matrices and to access it. And there's a whole bunch of like compute cycles that GPUs generally help power that kind of write transactions to this matrix or set of matrices, right? So there's, I guess, like the three layers, right? There's the interface with my ChatGPT, there, or my whatever text bot that I'm talking to. There's a bunch of infrastructure in this middle layer, and that's where providers like AWS or Azure or like other infrastructure providers come into play. And then there's the actual language model on the back end, and that's where like you have these kind of open source or open weight or closed source or like these kind of different actual providers of, for lack of a better term, this like matrix math or this linear regression parameterized thing.
Mm-hmm.
And so like along kind of depending on the question and the nuance and kind of the cognitive load of the question you're asking and the sources that, I don't know, like the amount of transactions that need to happen through these matrices to give an answer that the model deems sufficient. There are different, I guess, amounts of computation that need to happen, and different models will kind of give up at a different point, right? Like they might, like a cheaper model might only spend so many cycles on certain parts of the serving of a request or the answering of a prompt, whereas more expensive ones might be more willing to just spin or reprompt or try different permutations of interacting with these matrices, I'm assuming, and maybe have like different kind of controls around when an answer is deemed sufficient and when they'll give me a response. I guess, is that
Yeah, I think that's
Logical.
I think it's a fair way of putting it, especially, I
Okay.
mean, I know that we're speaking in a lot of metaphors and stuff, and I know that I'm not necessarily, speaking to the technical details at their most
Mhm.
specific ways, but I think that that's at a high level a very a good way of capturing it. And I mean, even just to summarize all of that, what you said, there's essentially a trade-off between, imagine I have the most generalized framework that can run any model. Um, I'm making a trade-off because it's so general and it can run any model. It's not going to be optimized for any one model's architecture or nuances or quirks. Versus if I build this extremely specialized engine that can serve only this particular model, but it can serve it extremely, extremely well because it has all these optimizations that I've spent hundreds of hours putting into it, then yeah, maybe I can serve this particular model at speeds that are 10 times my competitor. So that's kind of the trade-off that is happening. I mean, if I'm not mistaken, Cerebrus is really interesting because they've said, what if we don't stop at the software layer? What if we go into the hardware layer and build specialized hardware that allows
Yeah.
us to do inference for very specific models? Or at least I believe my understanding of Cerebrus and Grok and other companies where, they're really pushing into the hardware layer. They're saying, look, GPUs were not originally designed for LLMs. LLMs just happen to be, or even just deep learning in general. GPUs are just very efficient matrix multiplication machines.
Mhm.
And they solved the problem in graphics that CPUs couldn't. And so
Mhm.
when machine learning came around and the first deep learning winter happened in the late 90s, the experts at the time were like, well, deep learning will never scale because it's just way too computationally intensive. But we were able to solve those things with hardware. And so now as different AI labs compete on different types of models, and how are they competing on those? It's some combination and flavor of the data sets that they have, um, the actual architectures of the model that they're experimenting with and designing. Because one LLM is not the same as another LLM, both in size, in architecture, like you said, these different connections between different layers, like the way that the actual architecture is designed. I know it's a little bit abstract, but just kind
Mhm.
of think of it as different engines, right? A car manufacturer or a race manufacturer for an engine would make maybe different trade-offs for one engine as another. At the end of the day, they're both race car engines, but they make very different trade-offs and they're designed in very different ways. And maybe that's kind of the way to think about it as a high-level metaphor. And so um, to kind of bring it all back onto these kind of open weight models and where they're competing, yeah, like companies like Cerebrus have been able to really find the right abstraction layer by saying, what is the hardware that we can build that is purpose built just for serving LLMs? Maybe it's not so hyper specific to one model, but maybe it's specific enough to just large language models and the inference that is required to do and the capabilities that are necessary to do inference. What kind of hardware can we build there and software that kind of like makes this possible to be, as you can see in this graph, like they're almost 3 times or twice as fast or 3 times as fast as their next competitor for this particular model. So they're able to kind of realize huge gains in output speed and latency for serving these models. And that comes at a price. So if you have an application or a use case that is very latency and speed sensitive, then they have a great business model for you. Um, if you just have a huge amount of background jobs, maybe you're summarizing text, maybe you just have a bookmarking website and you're indexing bookmarks that your users have put, that doesn't need to be instantaneous. You can afford a slower provider and pay much less, Novita or Base 10, in this CoreWeave, in these examples, and they give you a much, much cheaper or much more high value uh, inference. You just don't get the speed for it. So it's just all
Mhm.
trade-offs that are really happening. And that's what's cool about where the open weight space is and where providers are competing. And I think if I could, read between the lines on what OpenAI and Anthropic are thinking right now, is that there's been this race between essentially the US and China in terms of artificial intelligence competition. The US labs are primarily closed source. There are a few that are open source, or at least provide their research out into the open, both in terms of the papers that they publish on architectures that they're experimenting with, perhaps the data sets that they have, and having them openly available. And then maybe some of the ways in which they train the models. There's kind of these 3 dimensions that you can play with. There's also, of course, proprietary or open knowledge on how to do inference really, really fast. But you can see that that's also being capitalized on and competed. So the US labs, OpenAI, Anthropic, XAI, Google, of course, is in the race. I'm kind of blanking on the other names, are primarily proprietary.
Mhm.
Then on the other side of the pond, what's really interesting is the Chinese AI labs have just historically been releasing their models openly. And at the inflection point after, I think it was GPT-2 or 3, maybe it was, do you remember which ChatGPT like kind of blew up OpenAI and like took them to this next level? I forget. It was around there after GPT-2,
Yeah,
GPT-3.
back like 2 years ago.
2004.
Yeah.
Because back then, OpenAI still released their models openly. I think GPT-2 was the last open
I was gonna
release
say,
that they had.
I remember GPT-2 being like, I remember actually like selecting that one out of a prompt. It was like one of the first times you could pick your model and like,
Yeah.
kind of test the conversation.
So after that inflection point, a lot of these labs, especially the Chinese ones, at least in my estimation, what I'm seeing is that a lot of these companies are not necessarily AI labs. Like you're seeing like a food delivery company come out with a large language model and you're just like, this is insane.
Mhm.
And they just have such talented R&D teams, and they're doing this out of necessity to compete and to be, as competitive as they can for their particular services. So ByteDance, which I believe is like the
Yeah,
parent
TikTok.
company of TikTok,
Yeah.
they've just been absolutely crushing it on the, on the image generation, video generation, audio generation front. And I believe they have also some text language models as well, vision language models that are available. I'm not as familiar. I don't think that they're really competing there, but they're just absolutely crushing it on the image and video creation because that's so big for their particular business model. And all of that, they continue to release those openly. Um, and this is where it can get into like some geopolitics as to why that makes sense. Like, is it to undermine a lot of the US AI labs and to essentially render some of their, services less useful or less valuable? Maybe that's not the best take. Maybe it is. I don't know. I mean, this is something where I'd love to discuss, in more depth with someone that's like really familiar, with like the geopolitics of it. But this is really what we're seeing is that the Chinese AI labs typically releasing open weight models, the US labs are not. And so there was initially quite a big gap between what was available as proprietary and what was open. And there was different thought, camps where people were like, oh man, the open weight models, they're never going to get there. That's never going to happen. And there was another thought that it was like, yeah, these labs are going to catch up and they're going to, eventually actually match the intelligence of the proprietary models. There's also a third camp that's like, there's always going to be a 3-month delay and that, that's never going to really catch up. But whatever, it's all speculation. What we do know though, in practice is that the open weight models have continued to improve and they've continued to just, be excellent. And so what's interesting is that we're reaching this threshold where if a model is good enough to do a particular task, whether that's run a simple agentic workflow, be able to manage your calendar, be able to kind of take actions on your behalf, whatever that may be, write some code. If we've reached that point where those models are good enough, and we have, and they continue to put out improvements to these models, that's kind of what I alluded to earlier when we were discussing this, is that I'm really curious to see where we are 6 months from now, 12 months, 18 months, 24 months, where now the competition starts to be in like how small of a model can you produce while still retaining that same level of intelligence, to the point where now you can deploy these models comfortably on consumer hardware without insane hacks, comfortably on like even an iPhone or edge devices, we already have really small models that can be deployed there. It's just a question of how good can we make those models. And that's a scary place for the market to be heading towards if you are OpenAI and Anthropic, where the promise is constantly, like we need to be the, the overseers of the AI because it's too dangerous and it's too whatever and whatnot. And so it's this really interesting tension that I'm very curious to see how it continues to evolve, because I'll tell you what, like if there's a model that's, at the GPT-5-6 level of intelligence and coding capabilities and agentic capabilities, and I can just run it on my MacBook Pro, why would anyone necessarily... I'm not saying you're not going to use the proprietary model, but the number of use cases are, significantly diminished where you actually need that like top tier intelligence.
Yeah.
So really curious to see where this goes,
Well, I think there's a really interesting conversation about just like the incentives of the incumbent most intelligent AI lab, right? Like when Anthropic had this clear step improvement with like Opus, where they had this kind of 6-month window where they were clearly the most effective model for like most enterprise things you would want to use intelligence for, right? Like from coding to whatever, all the other different plugins and Cloud Cowork that they built. And it's like this last couple of weeks with GPT's new round of these models, Sol, Terra Luna,
5,
like these, and Grok. They're like, there's clearly competition, and they're catching up, and then it becomes clear that in the tailwinds, of those kind of largest providers, there's going to be a whole bunch of other labs and open weight labs that are just catching up, and then I guess
that's what the data is showing too.
Yeah, and then financially, it's like for Anthropic, right, and OpenAI, who are trying to IPO this year. There's a whole, the answers to some of these questions can have like literally are on the order of trillions of dollars of market effects. And so that was the whole, debate around Anthropic and some of the tactics that they've used to try to shut down the competition, or like, in my opinion, trying to basically regulate competitors out of the space and claim that, they have kind of these golden keys to solving AI, which I think is becoming less and less.
Or some of the, I think that there are a little bit of circus tricks, the whole thing with Mythos and that whole, that the model broke out of its sandbox and emailed the researcher. Like, just, they're so good at narrative. They're incredible at narrative.
Well, because 99% of people who listen to these stories don't work in the weeds of
they just hear that and they think of the Terminator. Like, oh, the AI broke out of its sandbox.
Well,
and
dude, because it sounds like something out of iRobot. Like when you describe the matrix multiplication on these, a massive amount of memory running these compute cycles to figure out, basically using math for intelligence. It's like my head immediately thinks of iRobot, like the, whatever, the core reactor of the evil robot that's just all ones and zeros flying back and forth, controlling all the robots. So it's like, for your average person, like you're basically describing something that sounds pretty like potentially dystopic. So it's like pretty easy to garner fear around it. And I think another interesting thing is just like, you can argue that these labs, they're really capturing all of like published human intelligence, right? Like because the currency is just written language, it's like you can unlock basically all documented human intelligence. And
that's the goal, at least. And that's where there's a lot of, there's been, especially from some of the top researchers, pushback on that, like, if you think about humans, we don't interpret the world around us purely through text form. That's crazy. We interpret it through vision,
images, videos.
We interpret it through the way we speak and what we hear. We interpret it through, the things that we taste, the things that we feel, the emotions. And so there's this notion of, kind of like world models, I believe is what they're called. And it's been quite the new buzzword. That'll have to be a topic for, next time, because that's not really an area that I've even like researched on or read on. But the whole idea is that I think like Yann LeCun, who was, I believe he was on the Meta AI team, one of the really big, let's say early pioneers of deep learning and the space. And he had a lot of influence on, early deep learning and where we got to today with the transformer architecture. And he was one of those big proponents that like large language models just aren't going to scale to the point where we get general intelligence or general artificial intelligence. And I mean, I just from my understanding and the experiences of what I've seen, it's like, yeah, these large language models are very impressive, like how far you can go just by taking text input and producing text output. Like it's crazy the innovation we've seen just around that seemingly very, very simple primitive. Just words go in, words come out. Really cool things happen. But the real world around us is much more complex than that. And so, how do we interpret vision? How do we interpret sound? How do we use those things to make decision and reason? And the whole notion of an agent, or like what is an agent from the earlier like reinforcement learning literature, is essentially someone or something that acts in an environment with a particular policy, and they're taking actions based upon that policy to maximize some outcome. So that's a very mathematical way of putting, of defining the space. But to some extent, you could even say humans are these agents where, we're interacting with our environment. Yeah. We are taking actions based upon some policy. That policy may be our internal moral compass, what we think is right, what we're interested in. And we are learning to essentially optimize this policy so that we can take the most optimal actions to achieve some outcome, whether that's making the most money or achieving happiness or, whatever the outcome that a human or humans or society want. And so going up to that next level will be very interesting to see where that takes us. And because then I think we have an interesting shot at AGI, but I don't know if that's something that we really want to do. It's like,
there's so much fascinating here and just in this whole subject. Because I mean, you start talking about human beings, it's like, well, the fact that we have biological systems that can store that information and make decisions and have like things orchestrating the different kind of biological functions in our bodies. Like it's wild.
Yeah, like have you know much about, have you seen a lot of the Neuralink human trials that they've done?
I heard one of the early trial participants interviewed. I've seen like a little bit about, honestly, I was more into it a couple years ago, I think, when it was a little heavier in the news. I've not seen like any of the most recent.
It's really incredible. I think I most recently saw an interview with one of the early human clinical trials where I believe the man is, fully paralyzed from the neck down, and he's able to control this, an interface through his brain, I believe, and play video games, control a computer, and just do some. What to me that seems just something totally out of science fiction.
Yeah.
I'm sure that there's tons of interesting science that explain how that is even possible.
Neuroscience is crazy. The fact that our brains are these like electric plus chemical
it's crazy
systems,
to me. I can explain,
wild.
Matrix multiple. It's almost boring, right? Okay, you just have this big matrix and math, and you put them together, and you turn the text into numbers, and you put it into the soup, and a number comes out. Okay, large language models. But then doing that and interfacing to a human and an actual organic biological being, to me, that is extremely interesting and crazy that we can even do that. So that's. Yeah.
Yeah, Neuralink is wild. And I think when you were talking about kind of the fact that language is the medium right now for like language models, be it audio and video and all these other kind of signals you can pull out of your environment. And probably a lot of signals that aren't even observable to us as human beings. I mean, we already know there's all these electromagnetic waves flying through the air, right? It is wild, like the world of robotics and like thinking where could that take us, right? When you figure out how to translate all these signals in our environment into these kind of mathematic processes and these kind of, I don't know, because I feel like we're doing a ton of innovation with language as kind of the primitive. But then, as soon as, as these robotics companies keep kind of unlocking that translation layer, right, and figuring out how to do it in real time. Yeah, it's crazy. All the things
I agree, because I think that there's a lot of these companies that are seeing how LLMs have affected the space and just how much capital is flowing into these companies, are realizing like, holy shit, like we just need more compute too, and we can do all of this stuff. Because take the robot vacuum that I have in my house. I recently bought one for our new house. I haven't had one in like 6-7 years, and the one I used to have was just like when they first came out, it just kind of
Pumping
blindly
walls.
goes around and it bumps into corners and it's kind of stupid and, whatever. So I just kind of expected some of the same thing. And I was legitimately blown away at how, the reinforcement learning and algorithms that have gone into training these little robotics vacuums. And they're, truly incredible. They can learn to navigate an unknown space, an unknown terrain. You put it down for the first time. It does a little exploratory loop around the house and it maps out the space that it can discover and that it's in. And it can like balance itself on terrain. If it goes over a rug or something or some kind of unbalanced surface, it's able to kind of spin up a little faster and balance itself and recover. If it pick it up and you put it somewhere else, it will basically do a little reorientation and after a few seconds determine where it actually is in this space. Like these are all really cool things. I mean, people are probably like, this guy's going crazy over a robot vacuum. But I mean, if you think about it, it's really, really interesting because it's...
Yeah, on the low level, it's pretty wild that they can install that and sell it to you for what they can.
Yeah, because that's, they don't have if-else statements that are, to some extent, yeah, but this is what this category of machine learning, the reinforcement learning space really unlocks, because you essentially give your agent a target, a purpose of, some policy that you want it to, or rather some value that you want it to optimize for, and it will learn the optimal policy for how to behave in order to maximize that. And so that just already has really, really interesting, research and stuff that's happening. You're familiar with Boston Robotics, right? Have you seen their demos?
Yeah. I feel like they've been our like impending overseers for the last decade.
Yeah. And I heard somewhere, I don't know how true this is, that they didn't even introduce any type of like reinforcement learning to these robots until recently. Like a lot of the early prototypes that were really, really impressive didn't even necessarily have a lot of that. I'm not really sure. I could be completely wrong because, don't believe what you read on Reddit necessarily. But some of these recent demos are just absolutely incredible. Like you can see the robot doing like backflips off of boxes and it can, run and recover like running on marbles or some like really weird, unstable surfaces. Like someone will shove the robot and it can catch its balance. So these companies have a huge vested interest in these, so-called world models, because you pair that with a physical device, the robot itself, and some brain or aspect of a decision-making engine. And you've got some, interesting use cases on your hand. So.
Yeah, it's wild. It is funny because when those things fail, it's pretty good memes. But
yeah,
they're
laughing at until they'll have the last laugh.
Yeah, I don't know. I hate the robot dogs. Just don't build robot dogs. Everybody knows those are going to be like the end of humanity, yet they keep building them. I don't understand.
It is interesting seeing the human kind of the psychological reaction, or what would you call it? Not really physiological. Maybe it's like a psychological. Like you've seen delivery robots where people in the streets are just like vandalizing the robot, and if you kind of think about it, you're like, it's a really odd thing to do. But people like it just kind of, I don't know, brings out this visceral
apex
reaction.
Predators, human beings, apex predators.
Yeah, I mean that's like it, dude.
Yeah,
like you see these people like vandalizing the whatever Waymo delivery. It's like this thing's just trying to deliver a pizza. People are like kicking the shit out of it. You're like, this is not good.
Yeah, people are always just fascinated by like anything that moves.
Yeah. So
yeah, it's a crazy time, and I think like the reason it's such a hot topic, I mean, obviously there's been these advancements, but like it finally got to a inflection point where the market followed the math, right? And like the market followed the, like financially, just such a large allocation of our economy now is like just funneling into power and compute and just research around these models. And so it's like, I feel like it's wild just because whatever, we're only 10 years into our careers, not even, or, I'm not even.
Yeah, same. More
and
or
it's
less.
like, the same concepts that we were learning, in college 10, 12 years ago are still like the pillars of kind of what drives this industry. But it's like now there's so much financial incentive. It is like a bit of a, a gold rush. And like, that's why when you pull up, I mean, that's what's cool to me is like you pull up these, these benchmarking that whatever you were showing, that artificial analysis website, it's like there are 10 frontier labs competing and 10 different labs for each dimension they're competing across. And those are only the most competitive ones. Like there's hundreds of these, or thousands of these labs, right, trying to compete in this space. And like we're hyper optimizing on all these parameters. Again, like similar principles to what was being done 10, 12 years ago, but now there's just such an influx of demand and investment. It's like, it's going to be wild to see as human beings continue to evolve, right? Like there's going to be 10 times more experts. I mean, there already are 10, 100, 1,000 times more experts on machine learning and artificial intelligence just because it's become the currency of our economy. So it's like, that's going to have a compounding effect too.
The piece that I find myself wondering is what's the end goal of all of this? Because to your point of if we end up with a society of machine learning and deep learning experts, it's like, great, but now we don't know how to do basic things like, grow crops or, produce enough food for the people, in the world. But I do ask myself often that we have this huge artificial intelligence race. Where is it a race to? Like, what's the finish line? Obviously rhetorical to some extent. There probably is no finish line, but I mean, to some extent, this is always the case when you're trying to optimize businesses, optimize returns, return on capital investment. Like these are just things that naturally follow. But I do ask myself sometimes, like, to what end? Like where, where,
well,
when do we end up somewhere where we're like...
The guy that's leading the charge just moved the goalpost. That's his strategy. Let's go to the moon. Let's go to like Elon.
Let's go to Mars.
SpaceX, it's like, I feel like their whole business model is like, hey, let's just set an extreme goalpost because that's, you can get a lot more runway when you have basically the most.
But to that extent, you're just like, all right, we made it to Mars. Awesome.
Yeah.
Now what? Like, okay, now to where? To the next planet?
Jupiter.
To like, like
the sun.
Totally interstellar, like travel. Like, I don't know. Is it? So, I mean, that kind of just poses the general questions of being and humanity itself. Which is,
I think it's all just like really fundamentally fueled by curiosity. I think that's like the best interpretation of it. Or like the most optimistic is like, the harder the challenge we take on, the more positive outcomes and side effects that will come, the more advancements and just improvement in quality of life will follow. And you kind of just got to absorb and process the fear and concern and kind of use that to calibrate any of the crazy negative side effects, but continue to believe that like we feel curiosity and are inspired for a reason, even if we don't totally understand it. And like we were saying, the fact that we have these bodies that are these crazy complex biological systems that make decisions for outcomes that we don't even always understand or think about. Like, well, there's a reason we all feel compelled to build cool things and help each other. And like, there might be some negative consequences, but like, as long as you believe in that on the whole, I think that it's, it's a mission worth continuing to pursue if you feel compelled to do so. The big thing is like, but if you feel compelled not to, you shouldn't be forced to. You can do something else, go play sports.
Yeah.
Do something more fun.
That is definitely the big thing. One of those things that I'm thinking about too, like you said, the curiosity, the intellectual curiosity and being able to dig and learn. Especially, I don't know if you felt this way as a software engineer or just at least someone working in the software or the tech space, that, a huge part of your job or what your expertise is understanding the notion of programming languages, how to write code, how to express logic. And you're basically solving these puzzles all day long. That's kind of one of the biggest things that drew me to this space. It was like this never ending, puzzle that you could just express such a nice balance and blend of, technical specificity and very rational thinking, but also paired with very, very creative, open-ended kind of problem solving, which I, fell in love with. And seeing that essentially from a harsh economic, just pure, utilitarian perspective, essentially that diminishing that like that the purpose of you as an engineer or a software engineer writing code, as much as I hate to say it, is slowly just that is becoming less of the job role, much less than I'd want to. I love programming. I love understanding code. I love programming languages. I think part of that is what's kind of made me think twice about the future of the of the industry itself, or what software engineers will look like, or what our job looks like, just because of how much I historically enjoyed growing in that area.
Yeah. Yeah, I mean, I think that is one kind of aspect of software engineering that like right now is being less emphasized, is like kind of the growth creative cycle, just because there is this urgency since all this opportunity exists right now that didn't exist a few years ago. But like inherently, that kind of curiosity and growth is what brought this big gold rush, right? Like it's kind of like in the quiet, dark hours, there was millions of software engineers doing that kind of pondering that leads to these breakthroughs, and then leads to this big rush of opportunity. I definitely like hear you on that front. I think I'm a little different in that like I like some of that curiosity, but I don't feel like that's what drew me to software engineering. Like when I first got into the field, I hated being on a computer and I hated like the philosophical part. Honestly, I was like, I just did it because I was like, oh, that's crazy that I can like make this little board light up if I type the right things into this keyboard, right? Like,
Yeah.
I guess more like I don't know, like the ape approach of like, oh, look, I can type here and see the output. So I feel like for me, some of the current stuff, like it's really exciting just because it's like the velocity at which you can do that has gotten so much faster. But like, you're totally right that like it's taken a lot of the learning and the understanding out of the discipline, at least like as it's being implemented.
At least the
today.
temptation there, we talked about this before, that the temptation is too high to essentially offload that hard and interesting part, the rewarding piece of learning. And I think that's sometimes why the gratification is not there, because you haven't worked as hard to achieve a result as you once did. If you looked at a 3,000 line PR in the past, you're just like, my God, who did this? Like, what are you doing? Like, this must have taken weeks. Like, slow down or whatever. Or like now it's just the norm. You just see these massive PRs. Like maybe it's just because it's a startup, but
no, I think it's true though. I think it's true.
The gratification of being able to put something like that together and ship it used to be massive. Now it's just another Tuesday that you get to do that. And like you said, though,
and it's like on the days you're not doing that, you feel like you're falling behind because you're like, oh, we could have.
Exactly.
We could have. Yeah.
But I am trying to definitely find, it's not that it's just the coding aspect that that's what initially drew me to it, or just kind of like the problem solving piece. But I've always loved, kind of systems and design and architecture, and being able to like design systems and reason through how, this thing should work. Back when I remember this was kind of one of the earliest memories that I have of like really falling in love with the space was I was doing an internship out in eastern New Mexico, so like just west of West Texas, and I was an intern. I was a sophomore in college, and I had just finished like fluid mechanics and like learning about just like these like how fluids move through systems, pressure differentials, like kind of the foundations that you learned your sophomore year of an engineering degree. And I went out to the field, and they had a big one part of the operational issues that they were having was like these water disposal distribution systems. And they were just having trouble with like allocating costs for these disposals. And they had this really big network of water disposals that would kind of flow from east to west, and it would dispose of water at different areas. And they were just having a really hard time figuring out how to like allocate these costs. And fresh out of the classroom, I was like, oh, look at this. It's just like a material balance problem, So I modeled it all out and kind of built this like simple material balance problem and modeled the system and the different flow rates, how many gallons of water were being disposed in like, in each location. And then looking at like the total invoices, you can just then like allocate the cost. And it was like, okay, pretty simple engineering problem. But it was such a gratifying problem to solve because I felt like I directly used the stuff that I was learning. I kind of worked hard at the problem. It ended up being almost like a side project for one of my interns. Like I was 3 months there for the internship. I maybe spent a month on this project, which isn't that long if you think about like an actual work project that's that big. But it was like the most successful thing I did in that internship, and they absolutely loved it. And I would kind of laugh. I'm like, it's not that big of a deal. But like being able to do those things, like I still remember the gratification of solving that problem. Whereas like today I could have just been like, hey, ChatGPT, like, well, how do I do this? it probably would have given me some over-engineered bullshit that like, who knows if it was correct or not. Maybe it would have worked. Maybe it would have just been like, all right, here you go. Here's like some half-assed answer that I produced in an evening. But it's like, there's no gratification in that. And yeah, okay, the business outcome may have been the same, but
Well, I don't know if the business outcome would have been this. Like,
maybe not. I
it
don't know.
depends
Yeah,
on the.
but
It depends. Like, maybe for that case, because like you're just trying to whatever. Not. It depends what you're solving for, right? If it's like, oh, we need to avoid the worst outcome, then yeah, maybe AI can solve a lot of those problems. But when you're in highly competitive spaces, I mean, that's where I think like being in a capitalist system is really helpful for, the US. Because when you have these super highly competitive, hyper focused markets, right? Like every advantage you can get leads to material improvements, makes things better for your users or gives you an advantage in the market, whatever it is. And like, that's where like the genuine alpha that your company gets is having people that can do that sort of reasoning, that are like actual disciplined engineers that know how to solve a problem and optimize a system. That's where you get like your actual competitive advantage, right? So like, I think any successful operation, you kind of have like the two competing sides. Like you have the sweat hour approach, which is like, we just need to get stuff done as fast as possible, turn things on for users, just kind of push the needle, right? And then you have the other arm, which is like, well, we need balance. We need to do it in an intelligent way. And I feel like it's like the yin and the yang or whatever you want to call it. It's like one follows the other. When you invest too heavily in like the just sweating through your problems,
the brute force,
the brute force approach, sure, it can get you maybe some advantage. It can get you a head start, but ultimately you're going to have to figure out how to balance that if you need to, balance your costs, balance your
or is it sustainable?
time.
Like if you're just throwing labor at the problem or just effort or money or brute force.
Yeah.
I guess I definitely agree with that. It's not that I disagree. Perhaps it's that most people probably don't expect the same level of gratification from their work that maybe I have come to enjoy as a luxury. And I have acknowledged that for sure, that I am very thankful I have been able to enjoy my work as much as I have, for the 10 years that I've been working out of college. And it's just, I've had long discussions with my mom about this, actually, about kind of the distinction between finding purpose in your life in general. And it doesn't necessarily mean that you have to find purpose in the work that you are doing or the thing that makes you money. And I've wrestled with that idea for sure, because on the one hand, you spend 8 to 10 hours a day doing this job, and you're doing that until you basically retire. So to me, I'm like, I better be enjoying what I'm doing. I'm not going to just like live my life to, doing something I hate so that I can just get by and make money, and then spend the last years of my life trying to catch up on whatever I feel like I missed in terms of like fulfillment. But on the other hand, it's like, you should find those areas in your everyday life and in things outside of work, so that you're not just purely tying your notion of success or your notion of happiness or fulfillment to your job. So it's this very interesting tension that I've wrestled with for a while, and I think it's an interesting thing to think about, especially now. I'm at this crossroads, as we've talked about, with how AI is changing the job function, where I'm seeing much less of that gratification that we talked about. It's made me rethink kind of the priorities, or in the ways that I would have to maybe like steer the ship to either find gratification in the work that I do, or just rethink the approach entirely.
Yeah. Yeah. I think you definitely need like different buckets in your life. Like at a high level, just different places you can go, or things you can put your time and effort into that help you feel fulfilled or fulfilled. I feel like for me, it's always like, and the thing I always say is like, I kind of try to have like a top level North Star of like, what am I trying to do each day?
Yeah.
And the one that I heard when I was in like college was the first third of your life you learn, the second third you earn, the third you return. So I'm like, okay, if I'm going to use that as my charter, it's like the first chapter of your life, you learn as much as you can. Second, you earn as much. Third, you give back and try to build things for others as much as you can. But it doesn't have to be like, the way I think of it, I'm like, it doesn't have to be a totally like serial thing, or it doesn't have to be one after the other. It's like you can kind of...
Yeah, because I think you should spend your life learning too. That's the thing.
Yeah,
you should
I think you should spend your life doing all three, right?
Exactly. Yeah. Maybe the balances shift.
Yeah. And I think that's something that helps me get through, like, when when I'm like, oh man, like this, maybe a particular problem I don't find that interesting, or I'm like this.
Yeah, we're in the weeds of something that you just like has to
Oh,
be
like, this
done, but you
sucks.
do not want to do it. Yeah.
Yeah, it's like, all right, maybe like step back. What am I getting out of this? Is this more of a learning for me? Is this more of
Yeah.
an earning, like a building an opportunity for me or the group I'm working with? Or is it more like a returning? Like, is this a chance for me to go deep and teach others, or to, I don't know, find something unexpected out of this that I can like help another
Yeah.
person who comes around not have to deal with this or whatever it is. But yeah, I think there's so many different strategies.
I think that that's also why I have found that I've been so drawn to the physical fitness aspect the last few years, is because that's given me, it's unlocked something in me that I just wasn't getting from those other, let's say, just the purely intellectual areas.
Yeah.
So I think I very strongly now believe that you need to have the balance of all of them. You need to have you can't just, I personally would not feel great if just like all I did all day was just, only investing in the physical side and only just fitness and exercise and like not exercising your brain in any way.
Mm-hmm.
But on the flip side, I also think it's not good to just, be doing purely the intellectual and the theoreticizing. Like sometimes you just got to go and lift some weight and push your heart and,
Yeah.
just do something really hard physically, something that challenges you physically and mentally. And so that piece has just really been a big grounding piece for me, that it gives me a sense of gratification and fulfillment. And, even when I've had a hard day working on something, especially on days when it doesn't feel fulfilling, where it just feels like you're grinding and you're just, like you said, like, what am I doing here? Like, what am I doing with my life? Giving, or my work at least, giving yourself to that physical kind of, giving yourself the gift of that hour of physical fitness at least, just helps balance your brain chemistry too. It's just so good for you
That's what you're supposed to be doing with
to just kind of like center how you feel and your emotions and like release that frustration. And it's just good for your health and your overall longevity and well-being, So
yeah.
that's like, man, that's like the best piece of advice I can give people, especially that are in this, you're working a desk job or whatever, like go exercise, like invest at least an hour, in your day for yourself, for your mental health. Like that's, especially being men, like that's, I don't know the psychology of men versus women. I know enough about being a man. I'm speaking to that the best form of mental health therapy is just like go exercise. Like it's just so good for you.
Yeah.
You know what I mean?
And it can be free too. It doesn't have to be expensive. Just go for a run or go move some stuff. But it is true. I mean, when you're
pick
trying
up
to
something heavy and move it 100 times back and forth, and you'll feel much better.
I moved a stove with my brother-in-law last week, and that was like the hardest physical activity I'd done in months.
How far did you move it, dude?
We had to get it from the garage up into the kitchen. We had to go up this tiny little staircase, so we had to lift the stove above the railings. We were going up the stairs. I was on the bottom. I was like,
yeah, your shoulders are just burning. Yeah,
holding this massive stove.
It's
and
great,
he's having
though.
no problem. He grew up on a farm. He had no problem. He just lifts the thing up. He's
Out of boy is farm boy.
I'm like, he's got the craziest strength. I'm like, man, how do you get that farm strength?
Yeah, dude, I love that.
But yeah, you really just gotta move your body. You gotta, like, when you get in that funk, or like you're feeling like you're just spinning your wheels, going and just like giving yourself a physical challenge. First of all, it'll make you realize like all your mental anguish is just completely
made up.
Yeah, like 99% of it is nonsense. It's just like you spinning your wheels.
It grounds you. It's like you said, it's like,
yeah,
do I need to be, will I care about this in a month? Will I care about this in a year? Will I care about this in 10 years? And usually the answer is no. And so at least it gives you perspective to just take a step back, take a breath, not take yourself too seriously. Especially for someone like me, can get like very passionate and like almost tunnel visioned in their work.
Well, I think it's tricky too, because like right now our industry is in a place where like a lot of people are going completely all in on this.
All in, or some people are just leaving because they're just like, I'm not willing to do that, or this is not a place I want to be.
Yeah. But those who are competing like the top level, there is a lot of people working 80, 100-hour weeks on the same problems.
Which is crazy.
And I just can't do that. Yeah, I can't look at my computer that long. My body will literally deteriorate.
I'll say that I don't think I've found something that I'm like that invested in. Like it's so hard I could do that for a short amount of time, but it's just not sustainable for me personally, especially if it's not something that you're just like 100% all in on the idea.
Yeah.
I don't know if people truly feel that way or if they're just convincing themselves that that's how they feel, because there's a big difference between convincing yourself of something or, kind of going
just
along with
inherently feeling it.
the status quo that like this is the place to be. And if you don't, do it, being driven by FOMO more than actual conviction that something is true. There's a big difference there. So not to try and be too contrarian, but that's kind of, the view that I have of certain people. It's just like, oh yeah, bro, like 3 years ago you were all in on crypto. Now you're all in on AI. Like, okay, make up your mind.
Yeah. Actually, just random aside, like this podcast I was listening to this morning, they were like, man, 3 years ago, 4 years ago, it was all about metaverse and crypto. Like what happened to
Dude, the metaverse
what
was
happened to
such
the metaverse, man?
such bullshit. It's just it's so silly. Like,
Yeah.
it's just clearly a thing that no one cares about or no one asks for or wants.
Yeah.
That it's just like, whatever Zuck decided is the future of revenue. We need a totally new category for revenue that we haven't unlocked because we've maxed out our revenue earning potential. It's like, oh, the metaverse. It's like a new thing, huge revenue potential. It's like, I don't know. Those are the things you have to do, I guess, when you get to that point. But it's just like, you're such a clown, dude. Like, you're such a clown. Like, no one gives a shit about this.
That one was just like like you said, a product that no one wanted. Like no one wants to put on VR.
Meta AI,
no one wants VR goggles. No one wants to live in a fake place. We already got.
But that's
a
the
real
thing.
world.
Like, no one wants that, and then yet you're just constantly being pushed narrative that like this is the future. That's what I mean. Is that you're pushed enough of that narrative. If you're around it enough, that if that's what everyone is talking about because you think that's what people want, and it's kind of that. Do you know what the name of it is? Is that a specific effect? But just maybe the herd effect, that you're just everyone around you is saying the same thing. You kind of start to believe the same thing that everyone is pushing.
Yeah.
And so to me, that is a lot of what's happening. Or, the metaverse was so ridiculous that I'm just like, the fact that people were paying real money for digital space.
Yeah, dude, like hundreds of thousands of dollars. Can you imagine you bought that property on
I can't because I'm
Main
not
Street
stupid,
in the metaverse? It's like NFTs.
I'm stupid
were the same
in other ways. So
NFTs were the same way though.
I know, right?
A lot of money.
That's just, to me, that's just all like YOLO speculation though. Like that, there's at least a human physical, explanation for the FOMO and like the same whatever tendencies that people end up with, like gambling addictions, that just like, I could make a lot of money if I buy this digital ape picture that I can resell. And then, someone's left holding the bag inevitably.
Yeah.
And you kind of just feel sorry that people would subject themselves to that. But there's certain other things that are just so ridiculous that I can't even wrap my head around how anyone would, that's why I said, like, no one asked for this. Like, what is this?
Yeah. It's been an interesting time. I feel like eventually we'll look back on this all and get to process some of the ridiculous things.
I am curious what the next big thing will be post AI. And
I think there's going to be a robotics chapter for sure. Like someone's going to come out with, I think that's kind of like the obvious next thing, right?
Do you think so? Like the next?
Yeah, just like with all of the advancement in like the haptics and the measure, or like
I saw someone basically equate AI to the toilet. They're like, at some point the toilet was completely revolutionary. Like it was a new thing. And it really changed everyone's lives. But then at some point, it's like, yeah, everyone has a toilet, dude. Like, stop talking about it. So I could just see that AI becomes so commoditized. Like, we get to that threshold point that we were talking about where the models are just so damn good and they're small enough to fit in your pocket that no one thinks twice about it anymore. And that we've kind of, achieved that next level of quality that it's just kind of it's table stakes. And so everyone moves on to the next thing. So I'm just curious what that looks like.
Yeah, no, I mean, that's really true. It's not that different than just like the next generation of Google or web search.
Or whatever the massive, yeah.
Yeah. Yeah, I don't know. I don't know what the next thing would be. I think that I think there's going to be a lot of like medical and just like device technology. The thing is, it's like people don't really want technology like that invades their space, so like I think robots, there'll be like there'll be use cases where there's like really big, just like financial opportunities for like the right person at the right time. I think it would have a much harder time becoming like that pervasive, just because people wouldn't like looking at robots.
Yeah.
But like just like
Or
there'll be
just
a lot of
like
like peripheral devices and stuff that I think make a lot of advancements.
It's not even just about like what the next big technological advancement will be. I'm just curious what the demand for that will be as society. Like I wouldn't be surprised if we see some form of a regression, not in the negative sense, but more of like a regression back to more human-like qualities and human focused interactions, where it's like we want less time being online or connected to a device, and just whatever the equivalent of like spending more time outside touching grass and talking to people is.
Yeah.
Like
No,
we
I
just
think
moved.
yeah.
Like we just moved houses here to this new neighborhood, and one thing that I've loved is just it has an old timey feel, in the sense that, like, first of all, I don't know what that is. It's just like it's a feeling that I have, and I just love that you see people outside. They're on their front porch. You see kids outside playing in the streets, riding their bikes, playing with each other, kind of like going door to door, ringing each other's doorbells, and it's something that I just like. It makes me so happy to see. Like that's how you know I'm getting old, dude. Like,
no, dude, it's
golly.
healthy. I honestly think that we're part of this like I would hope that we're part of this like generation that
like the big wake up.
That learned that we don't want, like you just said, we don't want to spend 10, 12 hours a day looking at a screen.
But that it's just not good for you physically, or that it's like mentally, physically spending that much time connected is just not good for you.
Yep.
And connected being the loose term, just meaning like you're just
on the internet
doing digital interactions rather than physical ones. So whatever that next thing is that enables us to be more human, I think is something worthy.
Yeah, I think the big thing that technology will always do is just the fact that you can basically travel through space. Like we can be on this call together. I still think there's a ton that we can do in terms of just like physical travel. I mean, that's what I always think would be sick one day, when you can just snap your fingers and I'll be in Houston.
That is, yeah, honestly, dude, that's a great point. Like that is a really, really awesome way of kind of like framing it, that like what kind of technology enables us to be more connected, like on a physical, like human to human level.
Yeah.
Where you have, like, will we get to the point where we have on-demand travel, like where you can, like you said, you essentially ordered an Uber for a personalized drone shuttle to Wisconsin that gets you there in like half an hour.
With no,
I don't know, do the math on that. How fast would that have to be? That's pretty damn fast.
Houston to Wisconsin in half an hour. Yeah, that would be.
That's faster than
2,000 miles an hour. I don't know.
Yeah, dude.
3,000 miles an hour.
That's moving.
Yeah. People do it though. Just got to get high enough.
Yeah, I guess.
Get to
just go up so that you can go over. Yeah. My brother showed me this thing.
That is what those the fastest planes in the world. What they do, they just
they just go up. Yeah,
just go higher.
Exactly.
No traffic, less friction.
When the new flight simulator came out, you could like fly one of those stealth planes, or one of those like whatever that plane was that Tom Cruise was flying in Top Gun Maverick. That he was testing out like Mach 10. Like my brother was like,
whatever.
watch. Yeah, he's like, watch. I'm gonna go from Athens to Cairo in like 4.5 minutes, and he just like went straight up and like over and back down.
It's wild.
So if you get, I mean, everything sounds like science fiction until like you get to the point where that's even possible. I think getting from here to there, meaning like time wise, it's going to take a bit, but there's so much opportunity just for.
That would be a graph I want to see. I want to see the graph of like years of time passed versus maximum accessible commercial speed.
Commercial speed.
Yeah.
Well, they're bringing Concorde jets back, which is sweet. Like boom, supersonic. Have you seen some of that news?
Yeah, I know they had those, and then there was a couple crashes, right? And they kind of
a lot of that was like
bad
bullshit.
Marketing. Yeah.
A lot of it was bullshit, like why they were grounded. Like it wasn't that the planes were inherently unsafe. I think a lot of that was like political as to why they were banned or essentially.
Because you could go to Paris from New York in like 2 hours or something. Or 2-3 hours. Yeah.
This was in the 80s, I believe. Like it wasn't like it's So now these new supersonic jets that they're going to be, I think I saw 2030 or 2035. I mean, it sounds like quite a while, but that they're planning on actually getting FAA approval or whatever the international one is.
Mm-hmm. Yeah, they go from New York to London in under 3 hours, 2 hours and 52 minutes.
I mean, yeah,
That's
and at that
sick.
point, that's just like, yeah, it's a cost thing. Like you're gonna have CEOs and big executives, to be from point A to point B. At what point do you get to have just the average person commuting from A to B? At what point do we get to where you can commute essentially for free, in the sense that like you could pick to live wherever you want and then like converge to work somewhere else?
I think I could see that in like 100 years, you're able to travel 2,000 or 3,000 miles an hour commercially.
I feel like as
Zero
much as I would
emission.
love that, I just see that being less likely, in the sense that we have clearly converged towards solving human collaboration through digital space rather than physical. And just like the
so
cost
is
of
it gonna
doing
get the
that,
funding?
like the fact that you and me are talking right now, how many miles apart, is kind of like evidence of that. It's like, why do you guys need to work physically next to each other? It's like you just work digitally next to each other. But there's something to be said, like I said, like working, there's nothing like whiteboarding, like an engineer group, like with a whiteboard in a room. Like it's just like the most powerful thing.
Well, dude, and I think that people sleep on the fact that like when you spend time with a person, you just get more efficient in how you interact, and especially like for working together. Like being on calls, yeah, you can get better at. But like if you sit in a room with someone or in an office with someone, and you work with that person for 3, 4, 5 years, you get to a point where it's like you can just there's like zero friction or overhead in terms of like how you
assuming you can work well together. Yeah, that's a good point.
Yeah.
It's been years
or it
since I've
becomes
worked in an
obvious, or it
office.
becomes pretty obvious like who you don't want to work with.
Yeah,
and that's honestly valuable too. Like when you're all in the same room, you're like, all right, I go to this person for thing 1, this person for thing 2. Like, yeah, and you definitely miss out on some of that when it's all digital.
Yeah,
but to your point, like I don't know. I don't know if it's worth the cost of all getting in the same room. Like clearly you can make it work well.
I would love. It's. People that know me like know that I hate commuting. Like I just hate spending time doing the act of commuting. It's not that I don't enjoy being in the same space as people. I actually really do enjoy that, especially when it's in balance. Like when I need to do some deep focused work, I'd rather just be on my own and headphones on, just kind of in the zone. But for highly collaborative, creative, like brainstorming, hard thinking work like that, it's very valuable. And also just like the serendipitous moments of running into someone and like stuff that you're working on or seeing what they're working on, just happening to get a perspective that you wouldn't have otherwise, like bump into them into the hall. Yeah.
Yeah. I don't know. I think that it'll happen. I think we'll move 5,000 miles an hour one of these days. They used to say 60 miles an hour, your body would disintegrate, and it didn't happen. So
is that true? Is that what
that was what they said when there was some famous thing, like when the Model T came out or something, like when early cars were being developed. There was a large group of people that were completely anti-car because they thought it was dangerous. They thought
that's like physically to the body.
Yeah, they're like your body will,
Well, yeah, you have to accelerate from 0 to whatever, like maybe, but if you do it at a reasonable time frame.
I don't think relativity was like common knowledge at that point. Yeah.
Dude, we still have people that believe the earth is flat. I don't think,
Prove it's not. How are you going to prove it's not?
You got me, dude. That's it. The earth is flat.
You got to start walking. You got to start walking one direction and make sure you don't take any.
What is the treadmill theory? Remember that was the treadmill theory, that the earth is a flat pancake and it just like circles around.
Okay, here's the thing. I'm not saying I believe flat earth, but I think like physically there's probably an argument you could make that like from the right reference frame, the earth is flat. Right? Like if you're moving in a certain way so that the way you're perceiving the earth
is flat. I mean, it's it's a simple argument to make in the sense that like, you perceive space flat because you can only see so far that you can't see like the full curvature of the earth. But like the first question I ask people is like, have you ever been on a plane? Like you can literally see the curvature of the earth. Like, I don't know what else to tell you that.
Or like if you ever see the horizon.
Yeah, it's not that hard to like rationalize that, or sit on a dock and watch, boats sail into the distance. Like, why are they getting smaller to the point that they disappear?
You gotta show somebody the horizon and teach them Pythagorean theorem and then see if you can convince them.
Yeah, there you go. you can't explain that kind of stuff with science. You have to like lean into the very real physical perception that we can all agree on. But even there, it's just like,
Yeah.
yeah.
Well, there's something else I was going to say, but I forgot. All right. That might be all we have for today.
Just abrupt ending. No, it was good, man. We'll have to think about what next discussions will have to be.
Yeah, I think
kinda
it'd be
curious
fun to
what you're
do
interested in.
if people are interested in like the AI talk, it would be fun to do like a more curated series around like the different, not even just AI, but like different kind of like tech.
Yeah. I
Like,
think
you
it'd
could, like
be really fun
AI
to
through different
spend.
lenses, like AI through an economic lens for an episode, AI through a political lens for an episode, AI through a
Yeah,
more like just deeply technical lens. Like,
different perspectives of people of like how they see it.
yeah. Because something I do think is really interesting is the whole like socialization, like the socialist movement and like the way that relates to AI and the fact that you do have like the whole body of human intelligence that like a small subset of the economy is really leveraging, and it like the fact that that is, I think, directly causing this whole like socialist movement. I think it's pretty
Yeah.
interesting.
I think it's a continuation of themes of the greater internet and just the notion of open source and open knowledge and having the ability to tap into any kind of information that you need to freely available on the internet and sharing your thoughts in exchange for consuming that knowledge. It feels like a violation of that contract in a sense that,
Yeah.
I mean, to some extent, this is kind of the same lesson of like the tragedy of the commons, is it not? To some extent,
Yeah.
that
Yeah.
like
No,
this is kind
yeah.
of the maybe not, but I don't know. How do you see it? Do you think it is to some extent the same argument there?
Yeah, man, I think it is fair. I think it just like it's happening on such a massive scale right now. Like kind of the balance between like capitalism and private enterprise versus shared communal good. And like people trying to draw red tape around like segments of intelligence, or I don't know, like the most obvious thing is just like whenever they put in a new data center, there's like, the local community revolts because they're stealing a bunch of our land or whatever and resources.
And
It's
it's
like
ugly and loud, and it's just it's
and
like
it's privatized, like it's a private company that owns it.
and like everyone else, like I said, like no one asked for this, So it's
Yeah.
this really interesting trade off between like, okay, yeah, do you want instant answers on Google to give you whatever answer to a question you have on demand for your very particular dumb question? Like, yeah, if you want that, then kind of I'm not saying that is the end all be all of like, that's how we're just going to like desecrate the earth and just build data centers and destroy. Like, I don't think that's a good idea. I think where it's really frustrating is when it's forced on you. The experience of like someone just like giving you an AI answer or just like responding with AI slop is like the most frustrating. That's going to be studied from a psychological perspective. Like it
already is. Yeah. I mean, like
it pisses me off. Like it just feels like a violation almost, right? Like you're just like, I'm trying to have a human interaction with you. And like, I'm not saying like quoting AI in your response or saying, yeah, I consulted Claude or I consulted GPT for this and it had this to say as a form of research, but it's just like, yeah, that what you're saying is not important enough to me that I'm going to outsource my response to chatbot and just give you this like wall of text slop.
No, I think that is like a huge, I mean, first of all, like citing when you used Claude, it's like, it's obvious when you used AI, like it's obvious
it's very
when you
different.
did, but it's also like, at least then it's like, yeah, there's a level of respect there of like, hey, you're going to see that this was not my own articulated thoughts.
It's like citing research that you've done research, whether you can call it research or not, that you just put a half-baked idea, into the box and out come magical sounding words. That's, I think, that one of the biggest issues too there of that, like I've seen so many situations where like I'll see someone will tell me like ChatGPT told me this or Claude told me this. And my immediate reaction is always like, I want to see what question you asked. Like, I don't believe that because I don't think that you asked a good question.
Yeah.
And that's a really tough piece where I'm just like, I call bullshit because like you probably asked the dumbest question or you're just like, explain why I'm right. And here's like your your text or whatever.
Yeah, that's got to be okay. So here's a startup idea, because
figure out the question that was asked.
Yeah, well, no, one thing that's been talked about a lot is like, is there like there should be a better way to just like hand over sessions or context when you're like, whatever, I'm talking to Claude, I come up with an idea, I want to share it with you and kind of work on it together. There's just got to be a better way to share the context of what led me to my the current state of my
versus
AI.
just like, here's a transcript that I'm not going to read because it's 60,000 lines.
But the startup idea, I say you take context and you rank the context that the person built for the AI. So like, you give it a score from 0 to 100 of like how intelligent or deep or like thorough was this interaction. Kind of in the same way that we started this with like our profiles of like, okay, here's all of our benchmarked index. What if you could just do like micro index of like, for the context being managed in this session, we're going to run a little, we're going to kind of just like poke at that context a little bit and see like, okay, how smart was this snapshot? Like, is this something worth sharing? Is this, I don't know. Like,
what is the essence of what this interaction is? Like, is it high value? What was it trying to achieve?
Yeah.
And, what direction did the conversation go in?
Yeah.
I could see that being helpful. At the same time, I could see it because it's like, who's going to be the judge of that score? You're probably going to use another AI agent or another AI model, right?
Yeah.
And it's like,
but if you come up with a good index, it'd be kind of a fun thing. You get like a little thing on the top, like going from red to green, and then like you can have little competitions for who can get.
No one likes it because it's just like 0, like you're stupid.
Yeah. Who can get well, it could be like that. Could be like how you do IQ tests. Like you have someone interact with this thing for like an hour and see what their max achievable score is.
I would get a 2.5 out of 100. Yeah, it's definitely interesting, and that goes into the eval territory, which I don't know if we talked too much about, but maybe that can be like a future discussion.
You could like invert evals. So instead of evaling the context or like the
output,
the AI, you eval the input. Yeah,
that's actually
that would be actually like they could do standardized testing that way. Like for the SAT or whatever, just give somebody a prompt coming from the AI, and then just kind of like let the conversation evolve and see how
just like
grade the person's intelligence. Yeah,
just what kind of a discussion they have.
I
mean, that's not a bad, even for the purpose of interviewing someone, right?
Yeah.
Like you could just have essentially the same like initialized conversation. And to your point, like, in SAT and standardized testing where it's like, what is it, the creative writing piece or like the reasoning piece? Even just like inverting that, like seeing how good of a question you can ask to discover, like, let's say you give some topic that's completely made up, like some fictional characters in a story or some fictional environment or some fictional form of, pseudophysics. And you could only discover that by asking the right questions or good questions and then seeing how close or where people arrive at through the process of asking the right questions. Because that's oftentimes what you see is like people that are good at asking really good questions will oftentimes get much better answers rather than just like solve this thing for me, right? Or you just like throw you give 0 like reasoning into what you're trying to do. Those are all really interesting notions, though.
It's kind of like the evolution of, I know the GMAT does. There's like a whole bunch of different branches you can walk through the test depending on how you're doing.
And really, I didn't realize that.
Yeah, so like if
it kind of like evolves to adapt to your kind of level, and like it pushes you more if you're doing well. Or,
exactly. So it can like kind of slowly figure out where you are, and then do more nuanced benchmarking to get to your final score.
Very interesting.
Yeah, so they have like this whole decision tree of what question to give when. And so like the thing they say to test takers like is if your questions keep getting easier, you're doing poorly. And if the questions keep getting harder, like it's a good sign.
Yeah. I'm crushing this test, man. This is so easy.
Yeah. You're on question 10. It's like, what is your middle name?
Yeah, not a good sign.
Yeah, there's still like a lot of, I don't know, there's a lot of fun stuff you can do with AI. But to your point, like 90% of it no one asked for, except for like extremely nuanced researchers. But it does turn everybody into like a pseudo-intellectual. Like it makes me feel a lot smarter because I feel like I'm having more elevated conversations all day.
But it's so hard to cut through the shit.
Yeah.
What was the name of that theory that I briefly mentioned it with you? We were talking at some point. It wasn't on the podcast, but I wish I had the name on hand.
What is it, like a theory about how you perceive yourself or something?
It's essentially I don't know if it's a theory or a thesis or whatever it is, that essentially the time that it takes to disprove bullshit is like 10 to 100 times longer than it takes to like produce it.
Mm.
And it's probably just a corollary of just like entropy. Like,
Yeah.
okay, like it's really easy to just create chaos, and it's much harder to structure chaos and like reduce it to something structured. So it's probably just, this some artifact of that. But that's basically it, right? That it's like it's so much easier to produce just absolute nonsense or pseudo intellectual sounding content, whether it's malicious or not, or whether the intent is bad or not. And it just takes so much longer to disprove it that like you're just always on the back foot if someone is spewing garbage versus like, trying to actually put together a coherent and cohesive thought.
Well, and also a lot of the time the actor trying to make sense of the garbage is listening to the garbage to try to make sense of it. And whatever the source of the garbage is could care less about what's coming the other direction.
Yeah.
So it's like, it's like a race against somebody who's
you're losing you're fighting a losing battle at that point.
That's whatever like, your output is, they're not gonna.
It would make me so mad as a kid, and it still does. And it's like, when someone's being illogical and you're just like, their argument is so illogical and it makes me mad. It's like, you being mad about it is not going to help, because throwing more logic at their lack of logic is not going to make them be like, oh, wait, I'm illogical. They're just like, if they're inherently illogical or ignorant, you're fighting a losing battle.
No, it's true. Yeah, you gotta take your thoughts to somebody who wants to hear, or take your logic to somebody who wants to process it.
Yeah. Or where actual kind of fruitful discourse can exist, where you clash and find good. Like it's a fruitful clash where you're really exploring ideas and you have an open mind to seeing things in a different way, given sufficient evidence.
It is crazy though, just like with respect to language models, that like you went from 5 years ago where like any input token into a language model was being measured and for like pretty nuanced questions and benchmarking and analysis. And now today, everybody in the world can use it, and 99% of it is just complete nonsense.
Yeah.
So it's like, I mean, it has been commoditized like to the token or to the...
It really has, yeah.
The prompt. So like, yeah.
And not just that, it's like everything. Now we have this convergence of like models that understand images and audio and even video and text, and models that can produce, whether it's through a router or whatever, but can produce text, can produce model, can produce image, can produce video. It's like it's just because the quality is not there yet, but that feeling when you see AI generated images that are just complete garbage.
Yeah.
And you're like, this is embarrassing. Like,
well, the thing is, it's like with AI, we have like an audit log of all of these, or somewhere there exists a database with an audit trail of all the words and interactions with AI. Like historically, maybe 1 in every like trillion words spoken was actually like original and meaningful and advanced humanity. Yeah. And it's like, and those are the ones that got saved to the database of human knowledge. And now it's like, well, it's all in there. So who's gonna...
That reminds me of a short story. I think I told you this, that I was a good friend of mine recommended Jorge Borges. He's an Argentinian author, and he has a collection of short stories called Fictions. And one of the stories in there was called The Library of Babel. And essentially, like the synopsis, or at least my takeaway of it, because Borges is very, very... The stories are usually like very short, very... I don't want to say cryptic, but it's really up to you as the reader to determine what you want to take away from the story. There's not like a very clear takeaway. You have to sit there and ponder. So the basic idea of this short story, The Library of Babel, is you're like just dropped into this vast, infinitely and like never-ending library that has all possible, like I think 400-page books of a certain format and character set. So like any possible permutation of words and text that can fit into 400 pages that follow a specific structure, number of words per page, and number of words per paragraph have just been published into these books, whether they're complete nonsense or whether they're the complete work of Shakespeare. It kind of explores that idea that essentially for a given, finite set of words, or let's even just say for a specific language, you could conceivably produce a near infinite, but probably finite number of. It's kind of that paradox, right? That it's effectively infinite, but if you do start from a measurable number of words and limit them to whatever 400 pages of a book, you could conceivably produce a finite number of books where probably all of them are nonsense, but some very small percentage are not. So it's that story is so interesting. It's from like the 1940s, I think. It really resonated with me in this AI generated content era.
Yeah, no, that's fun. That is because that's literally what AI does, right? They just try to solve that problem by giving weights to the words. Yeah, that's cool. It is crazy how much of like the modern, how much of technology we use these days is just grounded in like millennia of experience, like of just human experience, right?
Yeah.
Like, so much of it is like intuitive stuff that we've figured out how to reproduce.
And that's ultimately too, kind of closing thoughts here, ultimately why I'm still so interested and so optimistic and, pro just human interaction, because ultimately LLMs in the way that we know them are, echo chambers of our ideas. And that doesn't mean that there's not interesting things that you can learn, or because most of the things that exist and most of the knowledge in the world that we have, we don't know all of it individually. However, in the slice and the corner of the universe of the things that we do know, there is some limit to what, an LLM is going to produce, and it's not going to be something innovative, and it's not going to be something that is completely unique in the sense that, that is, revolutionary or actually maybe original as a thought. And even if it was, you're like, is it because a human, or is it because the model like intellectually put together this sequence of characters, due to its capacity, or is it just because it just was able to randomly generate this sequence and it happened to produce a good sounding answer? So the more AI generated stuff that we have, like we haven't seen this like a recursive self-improvement of models yet, where it's just like the model just keeps getting smarter by like talking to itself or talking to each other or producing new ideas. So more power to original thought and using your brain as a human and the importance of it.
Yeah, it's definitely a tricky horizon to measure, but also like I kind of agree. I don't think AI can or will ever really move the needle. Like it catches everyone up. It
or at least in its current form. The term AI has been it's really encapsulated like, okay, large language models.
Yeah.
And just saying LLMs, it's just like easier to say AI, but maybe there is a day where that does happen. I see that as unlikely in its current form, and like specifically large language models. You know what I mean?
No. Yeah, I mean, I think most of what the value that that language models have brought, a lot of it is just around like all the infrastructure and brute force and automation that's come with it. That helps to create like a common, or that this kind of raises the floor. But to your point, makes it
raise
harder.
The floor, but not the ceiling. Yeah,
yeah, it brings the ceiling down to the floor as well.
Yeah. To some
Just
extent,
kind of makes everyone. Yeah. One other thought that I have is even like the smartest person you ever know, like 90% of what they say is just irrelevant or not thought out, or just more babble. And so,
which is fine, right? It's
totally fine. It's just like it's funny because like
it's like acknowledging what it is, though. You know what I mean?
Yeah. Yeah, that there are like peaks and troughs and just communication in general.
Yeah. But it's also timing too. Like none of what we've said today is original in the sense that these are novel ideas. These are all things that we have heard from other places, other podcasts, things we've read. our experiences in interacting with all of the material that we've discussed today. But maybe deep inside there's one idea that sparks an idea in someone else, or that's kind of the beauty of creative thinking and how you can synthesize things from different places. But they don't have to be original in the sense that everything that you hear is going to be original. Like that's, in fact, hearing original things is hard for your brain. It's unfamiliar, right? When you hear something, it sounds almost outlandish. So yeah, whether AI assists us in continuing to push our boundaries for creative thinking and problem solving, seems like there is some promise in some areas, and in other areas there isn't. But got to stay optimistic with what you can do. Yeah.
Yeah. I think that's kind of what to me is fun about doing a podcast is like just kind of getting to rehash conversations we've heard, or I don't know, just make up random thoughts and ideas and see what
see where we go
and what we can blend together and what's interesting and what we're drawn to and what people that listen want to hear. So
for sure, man. Well, thanks, dude. I really appreciate you having me again. Hopefully we'll have more of these discussions. It's always fun exploring these topics and ideas.
Yeah.
Kind of seeing where they take us.
Yeah, and keep it going.